I have given 2, now I'll make it 5. Feel the difference. You will find the sine wave to be more and more crowded. You see that? I make it 100. You will just see shade. You will just see shaded sine wave. As you compress more and more, what happens? The visibility of sine wave becomes poor. So one more level compress பண்றப்ப the sine wave energy becomes almost 0. Okay. So you have to find till what level you can compress your waveform so that it is looking intelligible. So this is I have given a scaling factor of 10. So it is looking like a sine wave. So as we compress more and more, the signal tend to go to 0 because energy becomes 0. When energy becomes 0, the signal will not exist, right? So when I give 100, you could see the amplitude. See the amplitude is 10 power minus 13 something you're getting, right? Which is almost equal to 0, right? So when you start compressing your signal more and more, the energy component becomes 0. You have to fix a period, fix the scaling factor, how much you want to compress. Okay, so I have stopped here till 10. So this comes only by trial and error method. So you cannot say till how much point your signal can be compressed. You have to find that by using trial and error method. So when I give a value more than 1, the signal is getting compressed. Definitely, when I give a value less than 1, the signal will be expanded. So we'll see, try giving half. I am giving half. We'll run the code and see. You're able to see the difference. Original sine wave, 1 millisecond time period. Now I have given half. So when I given half, the sine wave is taking 2 milliseconds to complete. It is expanded in time domain. See, in the place where I have 5 cycles, here I have only 2.5 cycles because I have divided, I have multiplied by the scaling factor half. I hope it is clear. I will increase it 1 by 3. Let's see the difference. Just feel the effect of DSP on your signal. 1 by 3, 1 by 4, 1 by 100. Assume if I give 1 by 10. Half sine wave. Only positive half is there. If I give 1 by 100, will I get my sine wave? You are just seeing a portion of sine wave which is looking like a straight line. So the more and more you expand your signal, the signal value becomes approximate. It is not even looking like a sine wave you see. So again, the too much of compression and too much of expansion will actually damage your signal. In the case of compression, the signal value will go to 0. In the case of expansion, the signal will become approximate. Okay, so this is the second operation what you do on a signal. It is called as time scaling. So time shifting is the signal is moving along the left or right of x-axis. Time scaling is the signal is again it is being packed or it is unpacked. It is compressed or being expanded.